Okay, so again today we're talking about our irrational numbers. Again, irrationals, we have that prefix IR in front, which represents not, and rationals by definition, numbers that have a fraction form. Okay, so what we're talking about here are numbers that do not have a fraction form. And what we realized in class today, that a lot of those numbers are never-ending decimals, and two, they cannot repeat. Okay, so that's what they have to be. They have to be a never-ending decimal that does not repeat. All right, and we realized in class today that the only place we can find those are those unusual square roots. All right, those unusual square roots. So again, we got a couple sets that we need to realize. So for example, if I ask you for the square root of 81, that is 9, which you can write as a fraction. So that square root would be a rational number. All right, but the numbers we're talking about are the square root of 50. Okay, 50 does not have a perfect square root. If you would type it into a calculator, you're going to get some long, ugly decimal. Okay, so this is an irrational number. All right, now, so what are the expectations? All right, the expectations are quite simple. All right, if you're asked what the square root of 50 is, okay, you would be able to figure out the nearest whole number. All right, so what whole number is it close to? Okay, so that's going to mean that you're going to have to understand your squares. All right, so for example, square root of 49 is 7. Square root of 64 is 8. All right, well, the square root of 50 is going to be in between those two. All right, so the square root of 50 is in between 7 and 8. So to find the nearest whole number, all right, well, 14 places away. It's only one digit away here. So the square root of 50, all right, the square root of 50 is approximately 7. Okay, new symbol there, squiggle equals, and that's approximately. All right, we would use that when anytime we round. Okay, now that's one version. That's one way you could represent your answer. Another way is, you could just say it's between 7 and 8. It's between 7 and 8, and then you could circle 7. All right, that would be we're saying that it's closer to 7. Between 7 and 8, closer to 7. All right, so we have a couple ways you can answer this. A, you can write it out in a sentence. B, you can use a new symbol here. It's approximately 7. All right, but the whole goal here is that you recognize that the square root of 50 is not a perfect square. So we need to be able to come up with the two whole numbers that it's in between, and then we need to be able to recognize which one it's actually closer to. All right, so that's the goal here tonight. Not much different than that as far as homework goes. Any other question I would ask you is going to be very similar. So if I would ask you the square root of 110, okay, hopefully you would come up with, well, the square root of 100 is 10, all right, and 11 times 11, using this as a reference point, okay, 11 times 11, that would be the square root of 121. Okay, so the square root of 110 is in between 10 and 11. Now, which one is it closer to? Well, it's 10 units away from 100. So this would be 10 units away. This one would be 11 units away. So obviously it's closer to 10. So what would we say? Again, we could say that a couple different ways. Square root of 110 is approximately 10. All right. Or we could just say, you could even actually 10 square root of 110, and you could put 11 on the outside and circle 10. That would be acceptable by all of us. So again, lots of ways, but you just need to make it clear to your teacher, all right, what's the closest whole number to the actual square root. That pretty much takes care of it, guys. All right, have fun with it. It's a little bit different assignment, but I think you'll have some success. Bring any questions to class tomorrow. Have a good night.